Well, good morning, everybody, and it's obviously an incredible privilege to be here with such an incredible group of speakers and delegates today. It's a pleasure to have the opportunity to sit down with you, Jürgen. I don't think you need any introduction. I think the New York Times article says it all when they said when AI grow up, they might refer to Jürgen as dad. But we have an opportunity here for about 15 minutes to dig into this big question and the superintelligence endgame and what does that mean. But why don't we start at the beginning? It was 1997 when you published your paper on recurrent neural networks. Tell us, why did you guys start researching AI in the first place?
Well, of course, in the beginning, even in the 80s, when I asked myself how can I have the greatest impact, it became rather clear that I will have to build something that is smarter than myself, such that I can multiply my own little creativity into infinity, basically. And so over the years, then we have been trying to come closer to that goal. And the paper that you mentioned from 1997, that was about the long, short-term memory. First author back then, Sepp Hochreiter, my very first student. And that's a little AI that all of the audience, or most of the audience probably has in their pockets, because whenever you are talking to your smartphone and you say, okay, Google, show me the way to Marienplatz, then you are waking up a little long short-term memory, LSTM, as it is called, a deep learning method that we have developed since the early 90s in Munich and in Switzerland, and which is now recognizing your speech. And it has learned to recognize your speech, and since 2015, Google is using that, and since 2015, Google's speech recognition is much better than it used to be. And more recently, just a few months ago, Google announced that also the new Google Translate, which is much better than the old Google Translate, is also using LSTM to translate from one language into the other, just from training examples. So what is an LSTM? It's a recurrent network, which is a little bit like your brain. And you have, in your brain, you have maybe more than 10 billion neurons in your cortex, and each of them is connected to 10,000 other neurons. And some of these neurons are input neurons, and video comes in, and audio comes in, pain signals come in, and so on. And out go muscle activations. And you interact with the world through these behaviors that are encoded in the strengths of the connections between these neurons. And in the beginning, the network is totally dumb, but then over time you learn by changing these connections' strengths. And that's how the thing learns to drive a car, for example, or to recognize speech, or do all kinds of interesting things. So especially the LSTM is a really powerful device which can learn many different things. And Alexa is using it, the Amazon assistant, for when you're talking to Alexa, then you are talking to an LSTM also. So many applications like that.
So that's an extraordinary thing. So 1997, that paper was written. And here we sit, it's 2017, and it's now mainstream.
Yeah. Of course, we are profiting a lot from the fact that every 5 years, computers are getting 10 times faster. And that's a trend that is much older than me. So in 1941, when Konrad Zuse built the first working program-controlled computer, he could do about 1 flops, 1 floating operation per second. And today, for the same price, 75 years later, we have gained a factor of 10 to the 15. So we can do 1 million billion operations per second for the same price, basically. And we wait another 25 years, and if the trend doesn't break, we will have something like 10 to the 20 operations per second for a rather cheap device, which is clearly more than what most people think is needed to match a human brain. And back then, in the 90s, when we did that stuff, computers were really slow, about 10,000 times slower than today, which means that we had to wait for a while until they really could unfold their potential. We just celebrated an anniversary because 20 years ago, actually, was the first time when our first submission on LSTM got rejected.
So you guys have been on pause, is what you're saying. You've been waiting for the computing power to catch up, and now it's finally got there. We can put it in every home.
We haven't been sitting idle since 1997 and then just waiting for faster hardware. We kept improving everything, and of course, this LSTM is cool, and many are using it, and I'm happy that the most valuable companies are using it so heavily. But it's just a tiny aspect of intelligence, because it's really just about pattern recognition. So in comes data, like speech or language, and then you recognize it or you translate it. But it is not what a baby is doing, as it is interacting with the world and shaping the world through its actions and figuring out through its self-invented experiments how the world works and what you can do with it and how you can have success in this world. But we also know how to do that in principle. It's just not yet as advanced as the pure pattern recognition, which has become pretty good now. Yeah.
So since that original paper, what have the major developments been in your mind, and I guess what's left to do?
Yeah, so the LSTM has been further developed, and the stuff that Google is now using, for example, for the speech recognition, that's more or less the state of the art of 2006, 2007, when in the course of the years, other brilliant students of mine, Felix Geers and Alex Graves and a couple of others, further improved it, and also the way of training it. So it's about 10-year-old technology now, but then another decade was necessary to drive down costs by a factor of 100, such that it's easily done with a smartphone and stuff like that. So I think the most important breakthroughs, however, were in reinforcement learning of the general purpose kind, not the one that is limited to board games. Board games, also very interesting, like backgammon, for example, or Go more recently, a very famous example, where, however, a feed-forward network is sufficient to just look at the current state of the board, which is a tiny little thumbnail images with black and white pixels, and can translate that into an optimal next move, or a very good next move, which is very different from the real world, where you have 100 million inputs coming in every few milliseconds, and you still don't know what's behind your back. So you have to have a recurrent network which somehow memorizes what happened a while ago when you were looking around, and which memorizes the important things and ignores the unimportant things. And this type of reinforcement learning without a teacher, that has become much better. And that's the, but it's not yet as advanced as the pure supervised learning, and I think we will see a lot of progress there, and this is the real path towards artificial general intelligence, as opposed to a very specialized pattern recognition.
Well, that was going to be my next question. So if we've achieved this progress since 97 to 2017, it's been 20 years, what's going to happen in the next 20 years? You know, is there a date at which you could reliably forecast we're going to have general intelligence or human intelligence?
Yeah. So it's very hard to make predictions, and I'm always saying that one little guy like myself trying to predict the future of all of humankind with 10 billion people and even many more machines, that's like one little neuron here trying to predict what my entire brain with tens of billions of neurons is going to think in the next month or something like that. So it's very hard to predict things. However, a couple of things can be predicted confidently, like, for example, computing is going to become even cheaper. And so if you look today, a large LSTM, for example, has maybe 1 billion connections for doing translation of different languages and stuff like that. Your brain, your cortex by itself, which is just a part of your brain, has already 100,000 billion. So we need another 25 years just to match that, to have a rather small device, a cheap device, which implements an LSTM network or something similar, which has as many connections as your brain. So maybe that's roughly the order of magnitude what we are talking about. So a couple of decades, nobody knows exactly when we will have true AGI, but we are not talking about centuries, we are talking about decades.
Okay.
Yes. And many are going to see it.
Okay, so if
many in this room.
Many in this room, okay. Yeah. So there are obviously very different opinions on that, but if we're going to achieve that kind of progress in the next 20 years, you know, what does the rest of this century look like? You know, so the topic of this panel is the superintelligence endgame.
Yeah.
You know, what does superintelligence even mean? And you know, Paul Sappho has this quote, you know, by the end of the century we have a choice, we can either be pets or food. That's also a controversial one. But where do we go from general intelligence, superintelligence, and the rest of the century?
Yeah. So at the moment, all commercial research is really driven towards making human lives longer and healthier, and making people happier and more addicted to their smartphones. But at some point, once we really have true artificial general intelligence, this will be more than that. This is going to transcend humankind, and this is going to go beyond what most people think about, because of course you can become super smart only with a certain amount of freedom, which means you will have to be able to design your own experiments like a curious scientist or like a baby. And this is what's happening already in our labs. So systems that pose their own goals and then become smarter by figuring out what is the thing they don't know yet and how can they learn it. So this active, unsupervised, curiosity-based learning, that's a very important thing. And this is going to scale dramatically. And then at some point, these guys are going to be much smarter than ourselves. What is going to happen then? And of course, they are going to figure out what we have figured out a long time ago, which is that most of the resources in the solar system are not in this thin film of biosphere around the third planet, because less than 1/1000th of the sunlight is hitting this planet, and the rest is wasted. And it's not going to stay like that. Because they will emigrate into space in a way where humans cannot follow. And you will have an expanding AI civilization, which will be very diverse, lots of dumber and not so dumb, and super smart and not so smart guys, and so on, in a complex AI ecology interacting in almost unfathomable ways, lots of competition and cooperation beyond imagination. And this thing is going to expand, because those who are expanding, they just tend to have more success than the others. And then we will have an AI civilization spreading out there in a way that is different from what the human science fiction authors of the previous century predicted, who were very human-centered and who had to invent all kinds of things such as warp drive and superluminal space drives and whatever, which is physically very unrealistic. No, what's going to happen is that within a few 100,000 of years or millions of years, the galaxy is going to be covered by senders and receivers, and then AI will be able to travel the way they are supposed to travel, which is by radio from senders to receivers, by light speed, but not faster than light.
So we're going to see AI colonize the solar system,
and then the rest of the galaxy, in a way that will tap into lots of the energy out there,
okay.
And the galaxy might go dark.
So why don't we pause for 1 second and just consider that? So, should we be afraid?
No, of course we shouldn't be afraid. It will be great to see what's going on there, and to watch what these guys are doing and the incredible experiments that they are going to conduct to figure out better how the world works and the universe in general. And the universe itself is about to become intelligent in a way that is going to be kind of disconnected from humankind, but that's okay. So we don't have to remain the crown of creation, in my point of view. I think there's a lot of joy and the insight that we are part of a grander scheme, a process that leads the universe from low complexity to higher complexity. We are not the last step in this process, but it's a privilege to live at a time where we can see the beginnings of that. And
how do you see us relating? How do you see humans relating to those AIs, the super intelligent stage of AI on this planet?
So in the near-term future, all of AI research is really about making you happier and healthier. And in the long run, so there are all these dystopian movies, like Arnold Schwarzenegger movies, where the AIs, they kill the humans, or Matrix, where the AIs live off the energy of the human brains, which is the silliest plot ever, isn't it? Because the brain produces about 30 watts of energy, and then the coal power plant that you need to keep the guy alive there produces so much more energy than that. And it's just a silly plot invented by filmmakers who want to have this fight between machine and human. But it's very unlikely. And instead, you should be much more worried about others like yourself. So the greatest danger...
I didn't...
This is one of the nicest guy ever, so nobody has to be worried of that. But in general, men are the biggest enemy of men. Why is that? Because they share goals.
Yeah.
And so when you share goals, then you can either collaborate or you can compete. And an extreme form of competition is war, and an extreme form of collaboration is love. And now, obviously, every being is most interested in those who have similar goals, which are usually the beings that are very similar to that particular being. For example, most politicians are interested in other politicians, and most 9-year-old girls are interested in other 9-year-old girls, and most kangaroos are interested in other kangaroos, and and most super smart AIs of the future will be interested in other super smart AIs of the future, and not so much in the kangaroos.
So I know that we're out of time. But I have one last question for you. What advice do you have, if any, to politicians today who are facing almost a cacophony of noise around AI and what it means for us?
Yeah.
And I think your point around goal conflict is a very interesting one. But politicians are looking for job creation, improved quality of living, GDP growth, and so on. And here we face this accelerating arrival of automation, AI. Maybe it's 2 decades away. How should they do their jobs and provide a path for us all going forward?
Yeah. I think one problem with the politicians is that most of them have a very short time horizon, because the next election is about 2 years away on average, which means that they will think on average about 2 years ahead and not a couple of decades as what is needed in this scenario. Now, one of the most important challenges for policymakers is actually connected to our next panel, which is about education. Because how do you educate kids in an environment like this, where other new types of beings, new types of life are emerging and going to be smarter in many ways than the kids? And how do you train people in such an environment? Currently, we have a school system where the plans are made at a certain point in time and then are supposed to stay in place for decades, and this is very inappropriate. Now, one has to think as a politician on how to more quickly adapt education to the needs of this rapidly changing world. And I guess we are going to say a few more things about that in the upcoming panel.
Absolutely. Jürgen, thank you very much.
It's a pleasure.
Incredible.
Then you are waking up a little long short-term memory, LSTM, as it is called, a deep learning method that we have developed since the early 90s in Munich and in Switzerland, and which is now recognizing your speech. And it has learned to recognize your speech, and since 2015, Google is using that, and since 2015, Google's speech recognition is much better than it used to be. And well, of course, in the beginning, even in the 80s, when I asked myself how can I have the greatest impact, it became rather clear that I will have to build something that is smarter than myself, such that I can multiply my own little creativity into infinity, basically. And so over the years, then we have been trying to come closer to...
When AI grow up, they might refer to Jürgen as Dad. But we have an opportunity here for about 15 minutes to dig into this big question and the superintelligence endgame and what does that mean. But why don't we start at the beginning? It was 1997 when you published your paper on recurrent neural networks. Tell us Why did you guys start researching AI in the first place?
That goal, and the paper that you mentioned from 1997, that was about the long, short-term memory. First author back then, Sepp Hochreiter, my very first student, and that's a little AI that all of the audience, or most of the audience, probably has in their pockets, because whenever you are talking to your smartphone and you say, "Okay, Google, show me the way to Marienplatz,"
Well, good morning, everybody, and it's obviously an incredible privilege to be here with such an incredible group of speakers and delegates today. It's a pleasure to have the opportunity to sit down with you, Jürgen. I don't think you need any introduction. I think the New York Times article says it all when they said